Okay.
Mm-hmm.
You read question 2.1.
Does a doubling of an effect does the doubling of an object average speed always double the magnitude of its displacement in a given amount of time? Explain.
Okay. So it means like, let's say if I double the speed, the average speed, can I always double the magnitude of its displacement? Okay, the time is fixed. Let's say
Mm-hmm.
1 hour, sorry, not 1 hour, let's say 1 minute. You look at the diagram on the left. Okay, so the curve line, the blue color curve line is the path length. The black color straight line is the displacement. Okay, now let's say if you double the speed, you increase the speed, then you reach B. Now, will it increase the length of the black line? Yeah. Okay, that means if you increase the speed along the blue line, will you increase the displacement of the black line? Answer is no. Why? Because average speed is defined by the path length divided by time. Let's say we look at this example here. Okay, the average speed is the path length divided by the time. So if
Mm-hmm.
you increase your speed, you will only increase the path length. Okay, increase the
Okay.
path length. You will not increase the length of this straight line. Provided you don't take the curve line. Provided you take the straight line, then if you double the speed, then the distance covered will be double. Okay, one more time. If you are traveling along a straight line, okay, you are traveling along a straight line, let's say you double the speed, then from 1 meter per second to 2 meter per second, of course you will cover 2 meters in 1 second, right? You will cover 2 meters in 1 second. Now, but if you double the speed, but then you take round, turn up and down, turn up and down, the straight line distance not necessary, right? Not necessary double, because you are traveling in a curve. So in other words, now this average speed is a scalar quantity, is calculated based on the path length. Okay, now what you want to compare with is the displacement, and you cannot compare, right? Probably you can, let's say the displacement is from A to B, then you go up, down, up, down, up, down, then the displacement will still be the same. Or from the displacement is from A to B, just you travel in one curve like that, the displacement is still the same, right? So it will only be the same, right? Your average speed
Mm-hmm.
will only be the same if it is traveling in a straight line. So if it is traveling in the straight line, the displacement is actually what you are traveling. Okay.
Okay.
Any question about this?
No, I understand.
Understand? I thought I'm
Mm-hmm.
not very clear. Okay, right. Then you read this exercise 2.1.
Estimate the average speed of the Apollo spacecraft in meters per second, given that the craft took 5 days to reach the moon from Earth. The moon is 3.8 times 10 to the power 8 meter from Earth.
Okay, if you want to calculate the average speed, first of all, you have to take the change in the distance or the path length, you divide by the time. So can you change before I show you the answer? Okay, now what you can do is you take this 5 days, you use your calculator, you change to second. 5 days you change to second. Then you take this distance divided by the time that you have found, and you tell me what is the answer. then I show you. Okay or not?
Yeah.
You calculate, use your
Let me
calculator
change the 5 days to
to seconds, because they want the answer in meter per second.
Fridays to 432,000.
Yes, correct, 432 down. Then what is the
Okay.
speed, the average speed?
The speed, do the 3.8
Ah,
times 10 to the power 8 divided by 879.
correct. Okay. Now, first of all, you change the path length is 3.8 times 10 to the power 8 meter. The time taken is 5 days. So 5 times 24 times 60 times 60. So it's 432,000. If you want to find the average speed, you have to use this distance divided by the time. So
Mm-hmm.
distance divided by time is 800 plus meter per second. So you
Okay.
notice that the number here 3.8 is actually two significant figure. So this 879, okay, 879, two significant figure, but the time, oh, so anyway they round off to one, by right you can round off to
Okay.
two significant figure. It can be 870 meter per second, right? Around that. Okay. Any question? Now this one you know how to do, so we carry on. Okay, right. Now, what